In this video, we're going to talk about the multivariable chain rule. I've given you z as a function of x and y, and x is a function of t, and y is a function of t. Here's my goal. I want to find dz dt. Now you might notice something. Those are d's, not del's. That's because if I substitute in what x is and what y is into z, it's only a function of t. So I can use the d's to remind us that it's a function of a single variable. Now one way we could do this is we could plug the x in, we could plug the y in, we could take the derivative. But I'm going to show you how we do this with the multivariable chain rule. It's always good to start with what we're calling a tree diagram. Z depends on two variables, x and y. X and y both depend on t. I'm going to label each arrow in this diagram with the appropriate derivative. So this would be del z, del x, del z, del y. And down here I've got functions of one variable, dx, dt, dy, dt. Now here's what we're going to do. To find dx dt, what you do is you think about, dz dt. We want to think about all the trips from z down to t. We want to multiply the derivatives together down each trip from z to t and multiply those products together. So the way this is going to work is that dz dt will be, oops, almost wrote a d there, I need to write a del z del x times dx dt. That's what I get when I go down this path. Plus del z del y times dy dt. That's what I get when I move down that path. And you'll notice, if you think about it, we've got dx's kind of canceling with del x's, leaving you with something that looks like dz dt. But we've got two terms. Alright, here we go. Let's start plugging stuff in. Del z del x. Well, that's going to be 2y. Times dx dt. That's going to be 3. Plus del z del y. That's going to be 2x plus 2y. Times dy dt, which is going to be negative 2 sine of 2t. Now, at this point you do have to plug stuff in, so you have to say what all these things are. So let's see, I've got 3 times 2 times y, that is 6 cosine of 2t, plus, alright, this nasty thing, 2 times 5 plus 3t, plus 2 times cosine of 2t, in parentheses, times, and this is going to end up on the second line, minus 2 sine of 2t. Alright, that's the multivariable chain rule. You create your tree diagram, you label it with the derivatives, you take all the paths from the top to the bottom, from z to t, you multiply the derivatives you get on each path and add them together. Okay, now that we've done that, we're going to do an example where we've got more variables. Okay, now we have z, which is a function of u and v, and each of u and v are a function of x and y. So our tree diagram is going to look a little bit more complicated. Here's our z. It's a function of u. It's a function of v. U is a function of x. And it also happens to be a function of y. V is a function of x. And it also happens to be a function of y. So let's say we want to find a partial derivative. Let's say we want to find del z del u. Oops, wrong variable. X. Del z del u would be easy. Del z del x is more difficult. So that means I want to make trips from z down to x. How can I get from z down to x? Well, I can go from z to u to x. That would be with del z, del u, and del u, del x. And also I can go from z to v to x. Del z, del v, del v, del x. Those are my two pathways. So when it comes time to take the derivative, I'm going to say that del z del x is going to be del z del u del u del x. That's that first path, plus del z del v del v del x. Alright, and with that, time to take derivatives. Del z del u. Oh, I've got to take the derivative of this. Oh my goodness, the v is just a constant, but I've got u times e to the u. This is product rule. So it's going to be the derivative of uv, that's just v, times e to the u. So that's the derivative of the first times the second, plus uv times the derivative of the second, which is e to the u. Very ugly. Del u del x. Oh, thank goodness, that's nice. That's 1. Plus del z del v. The derivative of this is u e to the u. Del v del x. Alright, well that would just be 1 over y. Whew, okay. Now it's plug-in time. Oh, alright, so what we have is v, which is x over y, times e to the u, that's e to the x, plus 2y, plus u, which is x plus 2y, times v, which is x over y, times e to the u, which is e to the x, plus 2y. Whew, that's all in parentheses, times 1, I won't write down the 1, plus u, which is x plus 2y, times e to the u, so that's e to the x plus 2y, times 1 over y. Whew, okay, we have taken a multivariable chain rule. Lots of work. Keep in mind that if I had changed my problem and I said, wait, I want to find del z del y, then I would have had to take the paths that take me from z down to y, and I would have different derivatives involved. Okay, there's our coverage of the multivariable chain rule.